Okay, so we began this chapter. We're comparing communication between, let's say, the nervous system and the endocrine system. So when we do that, is it fair to say that there's communication that takes place within the endocrine system? Well, chances are there must be if we're asking that question. Okay? One of the reasons or aspects we gave that type of communication might be blood sugar levels. That's something that we've talked about in the past as well. Okay? So when we look at breaking down the endocrine system, this has been like a work in progress. Now I know you probably can't see that on the camera, but when this was scanned in, I just had it always in my mind that it was just going to be one page because that's probably enough information, or the idea that if it goes into the drop folder, that just keep it on one page and has the hormones, their actions, and how these hormones are actually made or what they're composed of. So that's one aspect we talked about. And when we say how things have changed, okay, for some of you seniors, some of you probably recognize something like this. You should have seen the first draft of something like this. It was done in pen and paper, and probably not nearly as, I'd like to say, elaborate as what that might be. But things change over time, and they actually improve. We could say a lot of things about, okay, your football program that's been taking place in the late 2016s to 2020 or 2021, and then just think of how our volleyball program, it's changed. And we can say hopefully for say the benefit. But the thing is, we always don't get what we want. And I know, and that's something we have to, I wouldn't say expect, but something to accept. Because one of the things when you do go off onto your own in society, okay, it's not easy when you're out there on your own, even whether it's in college, but it's our job to hopefully point you into the right directions to make those types of decisions. So then when we look at what was handed out to you, this piece of paper, okay, what would be the basic and most simplest way that this chart gets broken into pieces? We use the NFL as an example. So we've got steroid action and non-steroids on here, okay? So this might look familiar, like, how many of you remember the dinosaur, what do I want to say? It was called Before the Dinosaurs. You categorize these into early vertebrates. Some of those were amphibians, some of those were reptiles, some of those were arthropods, and at the very end, they started talking about mammals. So on that chart, you've seen something very similar to this, how you would break those apart, especially the animal kingdom. Because how is a scorpion, which was Brontoscorpio, a mosquito or Meganeura, and there was one more, the Anomalocaris, which was a type of shrimp. Those are invertebrates because they lack something. They lack a backbone, unlike your amphibians, your birds, your reptiles, mammals, and of course that of fish. So vertebrates, invertebrates. That's the way you could break this apart. American Football Conference, National Football Conference. But in this case, we've got steroids and non-steroids, okay? But what is the categorical difference between a steroid hormone, not its function, but how is a steroid hormone different than non-steroid hormones? And you might not see it on here. Well, your body does produce these, that's correct. But the steroid hormones are synthesized from a specific type of compound. No, that's non-steroids. Okay, you're getting closer. And maybe we didn't have that. I thought cholesterol. That's right. So cholesterol is going to be the parent compound for what you see up here as these four, okay? No, there's 1, 2, 3, and then 4. So all of these are steroid hormones. So they're all synthesized from cholesterol. Then when we see non-steroid action, which we have here in the middle, that's breaking off into all different types of places. As you can see, this entire page was filled up. If it is AA, that must be what type of categorical hormone? What makes up that hormone? Amino acids. And then 2 P's, it is peptides. So that's where this book comes in handy. And if you would, open up to page 491. Okay, so there's some similarities on what we put up on the board. We'll come back to that in just a moment. So on page 491, when you see letter A, it's talking about cortisol. So if we were to look at this page and we find cortisol, okay, and that is on the far right-hand side, okay, up over here. It says it's a glucocorticoid. So if we didn't go any further than that, there's 2 things that we would like you to know about that. One, if it's a steroid hormone, it's made mainly of what in like letter A at the very top on page 491. What is that parent compound? No. That all steroid hormones have the same basic structure. That's what you answered earlier. Cholesterol. These, all 4, have something in common. They're composed of cholesterol.
So we start with the cholesterol base.
And then what happens is it's the different types of derivatives that you see on there that would differentiate between, okay, which steroid hormone is this? It could be aldosterone, it could be testosterone, it could be estrogen, any one of those, because they are composed of cholesterol. Then when we see glucocorticoid, that must mean that this steroid hormone has an effect on what type of levels in the blood? No. Glucose levels. Okay? So since it's a glucocorticoid, it's telling you that it has an effect on glucose levels in your blood. Well, what does it say that it does? Yeah, it lowers glucose metabolism. Okay? Have you ever heard of A or the stress hormone? It's called cortisol. Because one of the things that happens is when we go through different types of stresses in our lives, okay, it could be anything from, okay, this is the social part of growing up, okay? No one likes to be dumped, okay? You're going out with someone, they decide, we're going to break up with you, okay? What? Okay, so sometimes it's for the better, but at that moment in time, does it seem like that? Whether it was your idea or not, it doesn't make the process any easier. So what do you feel like after that, for those of you who have gone through this?
Happy.
And some people might feel happy, okay? So yes, I've got my hand up in the air because it's happened to me. It does happen, okay? So I think when something like that happens,
Sad and heartbroken and begged to not break up with them, and then they stopped. I met
process.
try and like get back together with them.
And maybe so. But that doesn't still,
Buy flowers.
it doesn't explain how some people might feel. And they could be your friends. And if they are, you can say, who can we pick on in here?
Me.
Okay? So some of your friends, like your lab partner here, might, I don't know if it's a good example of some of the answers you gave.
Oh.
The reason I say that is,
Preston had a heart breakup. You can go pick Preston.
so then you look at your lab partner and say, and it's a valid question, say, are you okay?
Oh, I would ask him if he's okay. I did ask him.
Okay. Because what happens when we're going through those periods of stress like that, like I said, it's all part of the teenage years of growing up, and sometimes it happens to adults too. We might not be feeling very well because this hormone, cortisol, is floating and circulating through the blood. So we already discussed what's the function of that cortisol. What does it do? It lowers your glucose levels. So then that person might not be feeling very well because they just don't have a whole lot of energy because they're going through this period of stress. I just picked cortisol for this because it was just some of the 4 main steroid hormones to go through. Now, when we look at a gonadotropin, which is also a steroid hormone, so we look at the name, gonads, okay? What does that mean to you in physiological human terms?
I don't know if I can say that.
It's part of the human body. Yeah, I mean, you're because we talk about that in cattle, pigs, humans, okay? We're talking about the reproductive structures, okay? So for men, it's testosterone or the testicles. For women, it's the ovaries, okay? And with that, during that time of puberty is where these hormones are really starting to elevate, and gonadotropins, let's look at what it says. It affects female sex organs, affects male sex organs. So we know that estrogen is the one that does it for women. It's testosterone that does it for the men. No matter what you do, you can't shut that off. It's physiologically impossible. We saw that on Friday, okay? Because what was the idea behind the episode for Home Improvement? It was called The Tool Man Delivers. What did the tool man deliver? A baby. So whether it's a human or any type of mammal, when that hormone, oxytocin, when that starts to circulate or elevate in the blood, those uterine contractions are going to start, and they're not going to stop until that infant or baby has been delivered. You can't shut that off. Yes, ma'am. Yes, ma'am. Okay? So we just talked about oxytocin. So that must be on here somewhere. Look in your lower left-hand corner. What does it say? It says oxytocin. So what type of makeup is oxytocin? It's certainly not cholesterol because it's not a steroid hormone. Polypeptides, okay? So then it's talking about a positive feedback, okay? We see something like that is on our schedule for, it should say the 6th on Thursday. That says negative feedback. But here, this is a positive feedback mechanism. So what does that oxytocin do? It causes something to take place on here. Uterine contractions, okay? Also lactation in mammals and humans. So again, once these hormones have started, you're just not going to shut them off. You can, in certain aspects for men and women. What's a hysterectomy then? Does anybody know? You could say a vasectomy as well. It means you're removing parts of those structures, and it could be for various reasons. One, probably the biggest reason is because there's been cancer detected in there, and it's rather unfortunate, so that's why this early detection is so important that, okay, your doctor's probably going to say, we need to keep that from spreading throughout the body, so then it gets removed because it's been found to be tumorous? Have cancer. Thank you, cancers. Okay. So, on page 491, letter A, cortisol, again, steroid hormone. Okay? And what we're trying to do is illustrate how you read this chart. One, is it a steroid or non-steroid? Two, then in the name, it's categorizing what these hormones do. If it's a mineral corticoid, back up to the steroid options, way up on top, okay, it talks about aldosterone. At least it should. I was pointing to the wrong side. Aldosterone. So it conserves something. What does it conserve? Sodium ions. And one of the ways that, I don't know, we like to describe as far as water retention is concerned, this hormone that gets released, that's a steroid, has an effect on this mineral. This mineral is called sodium. So if your kidneys are conserving these sodium ions, a good way to look at that is water follows that sodium. Okay? So that's how the body can retain water. Notice it's not the only mineral corticoid. There's other mineral corticoids on here. Like, for instance, right below it, it's a non-steroid hormone. So these mineral corticoids is PTH, which means parathyroid hormone. And then you also have calcitonin. Calcium is a mineral, sodium is a mineral. So that's why it's categorized as a mineral corticoid. Okay. We're going to skip letter B for just a moment. Okay. So I'm just reading what it says for figure 13.4. Underneath all these hormones, it says, does everyone see where it says in the figure 13.4, it says structural formulas of a steroid hormone, cortisol. And B, we'll come back to that. C, a protein hormone, PTH, or parathyroid hormone. With what you learned in biology, that's the first time you would have heard this, how do we know that parathyroid hormone is a protein hormone? Well, what's it composed of? No, those are steroid hormones. This is a non-steroid. What are alanine, valine, serine, glutamine, phenylalanine? Those are all what? The second one. Amino acids. All of those are specific amino acids. We learn in biology that amino acids are the building blocks for proteins. So that's why letter C we call a protein hormone. Then finally letter D, okay, oxytocin, we already categorized that on this table as a polypeptide hormone, okay? So just at a glance, okay, if polypeptide hormones like that of oxytocin and parathyroid hormone, which is another non-steroid hormone, they're both composed of amino acids. But in your mind, why do you suppose there's a difference between polypeptide hormones and amino acid-based hormones? What might, it's an observation we want you to make on page 491. They're both amino acids, but how is a polypeptide hormone different than an amino acid-based hormone?
A lot bigger.
The size, much bigger, much more complex. So parathyroid hormone has, and I don't even know how many that is, I'm just going to speculate. What would you think? Just 90? It's probably more than what you think. Okay? So for those of you tuning in a little later, okay, we're talking about all of these hormones. These are individual amino acids all linked together that make what we call parathyroid hormone, or PTH. Then this oxytocin is composed of what, 9 maybe? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 amino acids on there, but yet they are linked by what we call polypeptides. So oxytocin is a polypeptide hormone, where PTH is a amino acid / protein based hormone. Okay? Now, we said we would come back to letter B. Okay? So then, what's this? So for those of you from physical science and general chemistry last year, what is that? You don't have to give the specific name. This is valine. That's the specific name. But valine is a what type of compound? It is an amino acid. Why do you know that you're correct, but why are you right? Okay, so this type of family on here, this is an acid group. What is this then? It's an amine group. We know that this is what we call an amine because it's got nitrogen on there with 2 hydrogens. So this is the acid side. That's why we call it an amino acid. So what does this amino acid have in common with that of norepinephrine on page 491? It's the letter B. We said we'd come back to that. So what type of category would you guess that norepinephrine is? So you'd have to look at letter B at the bottom. It is a non-steroid. But what does it say down here at the bottom? Okay. All the way down here, figure 13.4, what does it say about letter B? It's a what type of hormone? It's an amine hormone. The reason we know that is because a lot of these things repeat themselves in chemistry. The periodic table is full of them, okay? Because those cycles, they go in such periodic functions where they repeat themselves. Same thing happens when in organic and biochemistry. An NH2 group means you have an amine group. Here we have norepinephrine, which also has an amine group to it. So that's why we know that that is a type of amine hormone. That's not on here, but we will talk about that because there we're just comparing 2 of them, norepinephrine and epinephrine. Okay, I think I had it in my mind that we would be talking about some of this, but we will keep this for tomorrow as we get closer to what we call this second messenger mechanism, how they're regulated. With a lot of these regulations, they're what we call feedback mechanisms, but we will get to that at a later time, so we will catch up to you next time.